Pause the video now, guys, and have a look. Can you get 8 out of 8 on question 3, 8 out of 8 question 4, and 8 out of 8 in question 5? So can you get 24 out of 24 marks, okay, on these questions, okay? Looking at some kinematics with calculus, okay? So pause it, have a go, and then press play when you're ready, okay? Now, before I actually start, guys, yeah, this is likely to be the last video recording of the year, as obviously A-level exams are coming to an end now, okay? I think as of tomorrow, if not on Friday. So I want to say, like, yeah, like a massive thank you for all the support, okay? I'm so blessed and grateful, okay, for every single subscriber, okay? And I cannot thank you guys enough, okay? Thank you for all the support this year. I really, genuinely actually appreciate it. So thank you for that. Okay. Yeah, okay. I thought I just said that, okay. But yeah, I feel obviously a bit emotional today. Okay. I mean, a part of me feels happy that, like, obviously there's no more videos, but I feel sad, yeah, because it is gonna feel strange not having to do like any like recordings for a while because there are no more exams suddenly for a while. But anyway, I hope you obviously smash, okay. I hope you smash your exams tomorrow, and I wish you the best of luck, obviously for your summer year and obviously for results day. But again, okay. Oh yeah, just to be clear, actually, sorry, yeah. But I am going to be around here in August here to obviously give my advice. Okay, but yeah, we will chat about results here, obviously, yeah, close actually. Do not obviously worry about it for today. Okay, obviously focus here on obviously mechanics and stats for tomorrow. Okay, but yeah, we'll chat about that more closer to the time. But yeah, sorry if I actually waffle. Okay, anyway, question 3. After t seconds, a particle has position vector r is equal to 3t squared minus 4i plus 2t squared plus 12tj meters. Okay, part A. Find the time at which the particle is traveling on a bearing of 45 degrees. Okay. Now, this is actually quite like a sneaky question here because it seems you find the time at which the particle is traveling of this bearing. Okay. Now, this is actually working out the velocity. So to work out the velocity, I'm going to differentiate the position vector, okay, or the displacement in this case. Remember that r is equal to displacement. So differentiating this, what do I get? Well, I'm going to get v is equal to dr by dt. Okay, so that will be 6 ti plus, okay, 2t squared here differentiates to 4t, okay, and then 12t differentiates to just 12, okay, j, okay. So yeah, this is quite like a sneaky question here because it's not been worded like the best way, okay. So read the question obviously carefully, okay, and if it doesn't actually make sense, yeah, miss it out, yeah. Obviously, do part B or part C, yeah, if it makes sense to you, and then obviously come back to, okay, if you're unsure, okay. So doing like a little drawing here, okay. So we're gonna have some component here. So yeah, it's gonna be some constant k, lots of I plus j, okay. And our job is to work out what this constant is, okay. So it looks something like this, okay, roughly, okay. So some constant k, so we're gonna have ki, and then we're gonna have kj. So we're going to have 6t, okay, equals k, and also, guys, that 4t plus 12 is equal to some constant k. You can remember, because obviously it's k lots of I plus j, okay? So yeah, we are looking at like, yeah, like the positive shear quadrant, yeah, so that'll obviously be a 45 degrees shear there, okay, or a bearing, yeah, 45 degrees, okay? And obviously fill in what you know, okay? So how can we work this out? Well, again, there are actually a few ways, yeah, to actually work this out. Okay, so let's just, yeah, obviously make that equal to k. Okay, so excuse the pun now. I keep saying okay as in like k as in short for okay, so I apologize. Sorry. So if we make these two are obviously equal to here, so that's going to equal to k. We're going to have 6t is equal to 4t plus 12, okay, because obviously k is equal to both here at each point. Sorry, guys, I think my keypad is going a bit funny again. I apologize. In like jerkiness, okay. If I solve the equation here, I'm going to subtract 40 on both sides here. So I'm going to get 2t is equal to 12. Therefore, t is equal to 6. Okay. So t is equal to 6. And that, guys, is my answer to part A. Okay. So that was quite like, yeah, like a tricky part question there. Okay. Because, yeah, it was worded, yeah, in a bit like a funny way. Because when I was reading this the other day, I was thinking, like, yeah, how on earth, yeah, are students actually meant to actually get that? Yeah, but it's understanding, yeah, that it's talking about, yeah, like the time at which obviously, yeah, it's traveling. Okay, obviously traveling. Remember, yeah, you're looking at speed. Okay, so that's part A done. What about part B? Find the magnitude of the acceleration of the particle. So we're going to differentiate the vector. The velocity vector. Okay, so dv by dt is equal to a. So a. Okay, so differentiating 6t, that goes to 6. Okay, so 6i, and then differentiating 4t plus 12, that's going to go to just 4. Okay, so we're going to have 4j. So magnitude means, yeah, I'm going to be using Pythagoras. So take the coefficients of I and j, square root it, and obviously put it under like a square root symbol. Okay, so the modulus of a, okay, of the magnitude of a. Sorry, guys, my keypad is been actually a bit funny. I'm sorry about this. I apologize. Okay, is the square root of 6 squared plus 4 squared, which again, if you bring it into your calculator, okay, that'll be 36 plus 16. Okay, so that'll be root 52, if I'm not mistaken. Which if you simplify it, it gives you 2 root 13, okay? Okay, that's fine, okay. And also, guys, yeah, sorry, a little actually note, guys, yeah, where possible, please leave your answer here, unless otherwise specified. Please leave your answer here in that exact form, okay? Yeah, okay, because it makes it actually easy to actually work with, okay? That's part B done. Question number 4 now. A particle P has acceleration 3t squared minus 4i plus 2t squared plus 4j meters per second squared, okay, where t is the time in seconds. First part, when t is 3, the velocity of the particle is 10i plus 20j meters per second. And an expression of the velocity in terms of p in terms of t. So from acceleration to velocity, we are going to integrate. So we're going to integrate this function, okay? So 3t, yeah, is going to go, yeah, for 3t cubed over 3s. So remember, you add 1 to the power and divide by the new power. So you're going to have t, you're going to have t cubed minus 4 integrates minus 4t, okay? So remember, yeah, think of it as minus 4t to the 0. You add 1 to the power, there's minus 4t to the power of 1 over 1. Obviously, divide by 1, yeah, doesn't actually change the answer. This is going to be my I component, okay, plus, and then if we integrate the next part, we're going to get 2/3 t squared, sorry, 2/3 t cubed, so I apologize. Okay, add 1 to the power, you divide by the new power, okay, and then 4t integrates to 4t squared over 2, which is going to be 2t squared, okay, j. Okay, now, back to the question here, because it's always important to obviously read the question. It says when t is 3, so we're going to substitute, okay, 3 into here, and then compare our coefficients for this, okay? So we're going to have 3 cubed, that'll be 27. 27 minus 12, that'll obviously be 15i plus 3 cubed, that'll be 27. About 3 is going to be 9. That'll be 18. 18 plus 2 times 3 squared, that'll be 9. 18 inches, so you can have 8 inches plus 18, yes, so you can have 36j. Okay, and I believe, guys, okay, okay, So I forgot actually. Sorry, yeah, I forgot to put. Sorry, yeah. So I forgot to put the plus C. Sorry, I apologize. Okay, I'm gonna have plus C there. I'll call it C1. I'm gonna call it obviously C2. Okay, remember, yeah. Okay, always remember, yeah, your constant of integration. Okay, because I obviously forgot it there. Okay, I'm now gonna use this condition to work out, yeah, and this here to work out what C1 and C2 are gonna be. Okay, so C1, yeah, is for I component, and then C2 is gonna be for that. Okay, so when T is 3, V equals this. So we're gonna have 10I plus 20 HDS. So we're gonna have 10I plus 20J. That's gonna equal. Now I'm gonna sub in here. T is 3. So yeah, what I said before actually was actually right. We're gonna have 3. Yeah, that'll be 27 minus 12. That'll be 15. Yeah, so that'll be 15 HDS. So we're gonna have 15 plus C1 KI. K. Again, this will become clear, yeah, as I'm going to work out what C1 and C2 actually are in a minute, okay? Because I'm then obviously going to compare coefficients, okay, to work out my answer, okay? And then I'm going to have plus, okay, so what did I have here? So yeah, I think I had here 36, I think, C2. Okay, again, correct me guys, yeah, if I've made a mistake there, okay? Let's just double check. When I put in T3, sorry, I'm trying to obviously work out here, well, obviously, use a Casio, yeah, if you can, okay? So 27, 9, 18 years. We're going to have 18 plus 18 years. Yeah. Okay. So 15 plus C1 equals 10. Okay, by comparing coefficient of I. So therefore, C1 is going to equal to minus 5. And then 20 equals 31 plus 36 plus C2. So 20 equals 36 plus C2. Subtract 36 here on both sides of my equation. We're going to get that C2, sorry, yeah, C2 is equal to minus 16, okay, if I'm not mistaken. Is that right? Yeah, I'm just going to double check on my calculator. Yeah, just so I'm not making a mistake. Yes, that's right. Yes, okay. Yep, on my calculator. Okay, there we go. Okay. Okay, so there we go. Yeah, so remember, sorry, yeah, guys, yeah, it's actually my fault here. Do not forget, yeah, obviously the constant C, okay, and obviously plug in your initial conditions, okay. So the velocity, remember, yeah, so remember that V equals this, yeah, okay, that's your V part, okay, and obviously you plug in T is 3 into here, and then obviously compare coefficient for your I's and J's, okay, that's part A done. What about part B? Initially, the particle is at point with position vector 2I minus 5J. Okay, so you're going to be careful here. So initially, the particle at the point with position vector, okay, find an expression for the displacement of P times D. So when it says this here, initially here, I think we're looking at when T equals 0. Okay, yeah. So the word obviously initially, okay, means yeah, so obviously yeah, T is 0, and then R is equal to this. And again, it's okay, we're going to integrate um the velocity vector, okay, or the velocity component. Obviously, not forgetting, yeah, I'll obviously plus C there. So we got, yeah, we've obviously got 40, and obviously yeah, we've got minus 5 there. Okay, and then we've also got minus 16 there. Okay, so let's not actually forget that. And again, let's not forget our constant. Yeah, this time actually have integration. Okay, because I know obviously I bang on about it. Okay, but obviously I've got habit obviously forgetting it myself. Okay, so integrating this, that will go to a so R, okay, or S, yeah, or D. Okay, R is equal to the integral of V, so that'll be a quarter T to the 4. Again, yeah, add 1 to the power, you divide by the new power. Okay, minus 4t integrates to minus 2t squared. Again, yeah, if you're unsure, please obviously check. Okay. Oh, oh no. I think my screen is actually frozen, guys. I apologize. Oh no. Guys, give me a minute. Oh, it's gonna move. No. Okay, guys, apologies actually about that. Sorry. Okay, so back to part B. So, okay, so we're gonna integrate the velocity vector. Okay, so R is gonna be the integral here. So we're gonna integrate here. So we're gonna have a quarter t to the power of 4. Okay, minus 2t squared plus c1t. Okay, and obviously we're now gonna have plus c2 as the new constant. Okay, oops, sorry. This is for the I component. Okay, I put J there. I meant to put I plus, guys. Okay, yeah, sorry. I'm trying to find my question. Sorry. So sorry. I'm looking back here on my piece of paper. Okay, so we're integrating here 2t cubed over 3. So that will go to, sorry, 2/3 here. T cubed here. So that'll be 2/3 t to the 4 over 4. Okay, and then we're integrating 2 to 3, yes, that'll be 2t cubed over 3, or 2/3 t cubed. Okay, and then we're going to be integrating minus 16s. That obviously go to minus 16t, and then not forgetting, which let's say plus c3j, and then our job is to obviously compare coefficients, okay, and solve for c2 and c3. Okay, that's our job. Okay, so initially, yes, so initially particle, yes, so initially means we're obviously going to start with t equals 0. Okay, so we got 2I minus 5j is equal to that obviously go to 0 minus 0, okay, minus 0. So we're gonna have c2I, okay, that, and then this part plus that will go, yeah, see, yeah, that'll be 0, that'll be 0, that'll be 0. You now plus c3j. Okay, so much, yeah, it's much nicer now. So comparing coefficients, yeah, c2 is equal to 2, okay, and c3 is equal to minus 5. Okay, so apologies, yeah, sorry if I actually cutting that part off there. Okay, hopefully, yeah, that makes sense. Okay, that part now. Okay, but again, would you, it's just obviously replace the c2 and c3, okay, with your numbers. So plus 2 there, and then we're going to have minus 5 there, or plus minus 5, yeah, obviously, yeah, which is minus 5. Okay, and then we're going to have the j component again. So yeah, so it's a bit squished. I apologize. That's part B done. Okay, question 5 now. A particle P has acceleration 3t minus 3I plus 2t minus 4j ms to the minus 2 or meter per second squared, where t is time in seconds. Initially, P has a velocity, okay, of this. Okay, same idea, so same idea. Okay, so velocity will be the integral of acceleration. Okay, so the integral of a dt. Okay, so we're going to integrate that. Okay, sub in our initial conditions. Okay, again, initially means we're going to start with t equals 0. Okay, integrate the function, compare coefficients, work out what I and j are. Okay, for your constants. Okay, so integral of this, that'll be 3t squared, yeah, over 2. Okay, minus 3t plus, we'll call it, I don't know, we'll call it C7, okay, for argument's sake. Okay, I, and then the integral of 2t goes to t squared is here, t squared. The integral of minus 4 goes to minus 4t, and then plus, let's say, c8, j, okay. So compare coefficients, okay, so put in t as 0, and obviously compare it. So that obviously be 0, that'll be 0. We got minus 4 equals c7, okay, when you compare the coefficients of I, and then when you compare the coefficients of j, okay, t is 0, that's going to be 0. So c8 is going to equal to positive 4, okay. So your final answer for part A will be 3t squared over 2, or 3 halves t squared minus 3t, okay, minus 4i, and then we're going to have plus brackets t squared minus 4t plus 4j, okay. Remember, I and j here are your xy plane, okay. Remember, you're always working in the xy plane, okay. I is your horizontal component and j is your vertical component, okay. So yeah, okay, and again, if you're unsure, please draw like a picture, okay, if you're ever unsure, okay, my question, okay. What about part B, okay, a bit more trickier. Find the velocities at the 2 times E is moving parallel to the vector 2j plus I, okay. So this is going to involve, okay, so we're going to have some constant k, lots of this, okay, plus that, okay. So okay, so this plus this here is going to equal k lots of 2i plus j, okay. The reason for that is, guys, is because remember, yeah, obviously from GCSE maths, yeah, that if you have two lines here that are parallel, okay, the one line here will be like a scale factor, okay, or a multiple, okay, of the other vector, okay. That's why it's equal to k lots of that, okay. So we're gonna have 3 halves t squared minus 3t minus 4 is equal to 2k, okay, when you compare the coefficients of I, and then we're going to have t squared, okay, minus 4t plus 4 is equal to k, again, comparing the coefficients of the j components, okay. I'm now going to sub in this to here, rearrange the quadratic, and then obviously get my solution, okay. So let's see, let's shift it, yes, let's put some more space there, guys. So we're going to have 3 halves t squared minus 3t minus 4 equals 2 lots of, well, in this case, we're going to have 2t squared minus 8t, okay, plus 8, okay. Rearrange the quadratic, make it equal to 0, and then obviously solve it, okay. So, sorry, yeah, I'm probably going to obviously missed out some steps here, okay. But when you do it, okay, your solutions are t equals 4 or t equals 6, okay. When you rearrange the quadratic here, obviously make it equal to 0, okay, factorize, complete the square here, or use a quadratic formula, okay, but they, guys, are my 2 times, okay, P, yeah, that is moving parallel to the vector 2I plus j, okay? So the last part is we're going to substitute in here t is 4 and t is 6 here back into our original, okay, components. And when we do that, when t is 4, okay, we get 8I plus 4j, okay, for the velocity component, okay, when t is 4, okay, and then when t is 6, guys, we get 32I plus 16j, okay, again, that's when we sub in here t is 6, okay, into our velocity vector, okay, components, okay, and again, obviously, yeah, so sorry if you're going obviously a bit faster there, but hopefully that makes sense. And then obviously check if you're unsure, okay, but yeah, we obviously solve the quadratic, okay, as we normally do, okay, make it equal to 0, factorize, complete the square, or use a quadratic formula. You get t is 4, t is 6, and the final part is to sub in those t values to work out the component vectors which are parallel to that, okay? So when t is 4, yeah, it's going to be 4 lots of 2I plus j, and you have 6 lots of, okay, yeah, 2I plus j, okay? Is it 32 actually, or should it be 12? Okay, yeah, that's fine, okay? Right, guys, that's the end of today's video, okay? So I hope you found it useful, okay? Okay, as like a last request, guys, yeah, please do consider liking, subscribing, sharing, okay? And I'll see you soon. Actually, all the best for tomorrow, okay? Show your full workings, okay? Remember to obviously try and attempt every single question, okay? And if in doubt, draw a picture or a diagram to help you. So draw a picky if you're unsure. Okay, but that's it for me today, guys. All the best and best wishes this year for summer. Bye for now. Take care. All the best, folks.